This video is going to go through the last section, 10.8, which is choosing the appropriate inference procedure. So the first thing that they will go through and questions that you'll see are just having you identify what type of sample we're looking at in a problem. So there's three different things that we're looking at. We're looking at one sample data, two sample data, paired data. There will also be questions that have more than one sample. So if it's, or sorry, more than two samples. So if there's three pieces of information listed, right, it would be that choice. So one sample data is inference procedures about one sample, only describe data be collected from one sample or group. So an example of that is this problem from previous experience. The owner of an apple orchard knows that the mean weight of Gala apples is 140 grams. This year there's been more precipitation than usual. The owner believes the weights of the apples are heavier than usual. The owner takes a random sample of 30 apples and records their weights. So he's taking one sample, a sample. Two sample data, inference procedures about two samples describe data being collected from two independent samples or two groups in a randomized experiment. So in the case where a teacher has two large containers filled with blue, red, and green beads, she wants her students to estimate the difference in proportion in the red beads. So each container is a population. They're taking beads from each container to complete two independent samples. Paired data is the result from recording two values of the same variable for each individual or each pair of similar individuals. So an example of this is if a shoe company wants to determine if their new tread on its top line of running shoes lasts longer than the original tread, they recruit 50 runners for a study. So this would be where they're creating samples here. Each runner will perform their typical workout wearing one shoe with the original tread on one foot and another shoe with the new tread on the other foot. So the way they're randomizing this is that which foot it's on is decided by flipping a coin. After 1 month, the runner will wear the new type of tread on the opposite foot. At the end of the month, they will record the difference in tread wear. So since we're looking at the difference in tread wear, not each one separately, that's going to be paired data. So each of these types of samplings create a different test that we're going to use. So we're just identifying the test. We're not performing the test in this section. So thinking about that, let's use those same examples and identify what type of test or inference procedure we would use. So the following are all of the inference procedures. So notice that there is either a 1 or a 2 sample, and then either a Z or a T interval or test. And so what we have already talked about is determining what kind of sample we have, which is the third item on the list here. And so what we want to think about then is the other two. So for the other two, what we have to be able to determine is, are we doing a test or are we doing an interval? And so if we see something where we're comparing values, we're saying something got better, something was higher, something was lower, something is different, that's when we're going to be doing a test. When we're estimating the true mean, the true proportion, that's when we're going to be doing an interval. So we're looking for those clues within the problems. Finally, the fact that if it's a mean or a proportion tells us which type of test or interval we're doing. Remember that we're essentially saying, is this going to be mu? Or is it going to be P, right? And remember, if it's a test, if it's a mu, it's also either going to be a T, interval or test, or if it's a P, it's going to be a Z, interval or test, right? So the fact that it's a mean tells us we should have mu and T in the problem, or in the test name. And then if it's a P, then we should have a proportion, we should have P and a Z in our inference procedure. So the first example, remember, we already know that this is a 1 sample. So if we're thinking about the other pieces of this, the first thing we need to look at is this a test or a confidence interval? So are we comparing values or are we estimating values? So if this is saying here that he believes the weights of the apples are heavier than usual, that's a comparison. So if I'm going to compare these values, that means I'm going to do a test. The next thing that we're looking at is, are we talking about a mean or are we talking about a proportion? And so here we've got the mean weight of these. So that means that because we have a mean, we're going to have a t-test, okay? And then from the previous problem, we already know that this is one sample because he takes a sample. Okay, so what this means is that this problem, and I'm just going to highlight the appropriate tests just to save myself a little bit of time here. So for example, 1, that means I'm going to have a 1 sample t-test for my mean. Okay, so I'm going to have a 1 sample t-test for my mean. So this first example here is an example of a 1 sample t-test for the mean. Okay, so next let's look at our second example, which was the teacher that has the 2 large containers filled with blue, red, and green beets. So first what we want to do are we comparing or are we estimating? We are estimating. When we're estimating, that means we're going to do an interval. Okay, and then we want to look at, are we talking about the proportion or the mean? We're talking about a proportion, which means we're going to have a z involved. Okay, so p always goes with z. Notice they shouldn't try to trick you with that in the problems, I think. Then we already talked about that this has 2 samples, which means that we're going to have a difference in proportion. So it's going to have P1 and P2 in there. So what this means is we are looking at a test that is a 2 sample. Let me just change the color here. We are looking at a 2 sample Z interval test for P1, P2. So 2 sample Z interval for P1 minus P2. So this test is going to be used for example 2. Last but not least, we have that paired data in the final example. I'm going to write over here on the side. So shoe company wants to determine if the new tread is better. So remember that if we're talking about it lasting longer, that means that we're comparing, which means we're going to do a test. Then we're looking at whether we have a mean or a proportion. And if we look at this problem, it doesn't really tell us a mean or proportion. So let's look at the third item to kind of figure that out. So with the third item, because we have the difference in treadwear new versus original, we're doing paired data. When we have paired data, it's always going to be the mean difference. So if I'm looking at the problems, there's only 2 that have a mean difference, right? And that's either a 1 sample t-test or a 1 sample t-interval. So we're doing the test. So that means that our result will end up being, sorry, I'm just trying to pick a different color. Let's do, let's do this color. That means that since we have a 1 sample t-test for the mean difference, that means that in this problem, even though it's not explicitly stated, because we're going to be looking at a mean. Okay, so you have all of those options for the type of test. Remember that you're asking yourself 3 questions. Is this a test or a confidence interval? It's a test if you're comparing values, if something is greater, something is smaller, something is improved, something has decreased, that kind of thing. That's a test. And then if you're estimating a value, that's when you're doing an interval. Remember that if it's a mean, you should have a mu and be doing something with a t. And then if it's a proportion, you should have a p doing something with a z. And then you have 1 sample, 2 sample, or pair data to help you conclude which type of inference procedure you will be using for that problem.